Good morning, everybody. Ladies and gentlemen, welcome back. Today is Wednesday, March 17th. St. Patrick's Day. And of course, this is your 3B class on Trig Identities. We're going to look at another example that's kind of new related to our video series on Trig Identities. It's question 8E from page 310. You want to pause the video to make sure you check your textbook where this question lies. I'll read the question to you though. On the left-hand side, we have sine 4 alpha minus cos 4 alpha is equal to sine squared alpha minus cos squared alpha. This is your first glimpse of seeing a higher degree polynomial. So if you want to pause the video, try your best to manipulate using the tips over here. Maybe you can't see it, it's in orange. Feel free to pinch and zoom in. And off screen, you have your trig identities, which I'm not going to read out to you. So feel free to pause the video and try this yourself. But let's get to it for the remaining that are here. Any volunteer from the class would like to help out Mr. Chen? Which side do you think is more complicated? The left side or the right side? No pressure. Adam? Left side. Yeah, left side is harder. Now, I'm going to change them in terms of x if that's okay, just so it's just a little bit easier. It doesn't really matter, right? Any questions? So I just try to make it x's because it's just easier. And right off the bat, just to annotate, anyone actually see a particular, I know this is a degree of 4, which many of you don't really are accustomed to. But what does it look like? Any volunteer from the class? What does it look like? It's okay. You don't give me the answer. But what does it look like? Anybody? Anyone see the answer? It's a binomial. And this is a subtraction sign. Anyone? Anybody? Bold enough? Tom?
Are they like terms?
They're not like terms. Nice try though. They're not like terms. Hi, Karen.
Perfect square.
It's not a perfect square, but it's related to a perfect square. Would you like to try again, Karen?
Different.
It looks like a difference of squares, even though Mr. Chen, I don't see it, and I agree, but it is actually a difference of squares. And so when you see your tips here, you kind of have to remember how to factor in difference of squared patterns. This is a classic one that many students don't really know because you haven't been doing it, but I'll show you what it looks like. Now some students, when they see this, but Mr. Chen, I don't really know how to do this. So let's just do it in algebra terms. And in some sense, in the blue, in the algebra terms, it kind of makes sense. Because a squared times a squared is a to the 4. B squared times b squared is b to the 4. And notice it negates those middle two terms. So this is true in blue. This is the idea. Don't get me wrong, please don't write this on the trig identities. This is technically wrong, right? But some of you realize, and if you look at our tips, some of you will see it now. Anybody? Maybe use this one here that I'm pointing to, that is, I don't know, anyone see anything interesting what we can do? Anybody from the class? Adam!
Sin x squared minus cos x is equal to 1.
Nicely done. Adam said, if you didn't hear the camera, ladies and gentlemen at home or you're watching this later, Adam said sine squared x is cos squared x. It's the Pythagorean identity. And it equals 1. Now I'm being a little silly. My stomach is growling. It's like, rawr. I'm hungry. That's the answer. And what do you know? Since the left side equals the right side, the identity is proven. So we take a scary kind of question, and I'm not trying to say it looks difficult. And again, no one memorizes this, but we try things, and I'm obviously trying to save you some time when you experience this yourself. Okay? So we're going to stop the video there.